Y'all hear me okay without a microphone? Is that good? Okay. My name's Cory Isaacson. I'm the CEO and CTO of Code Futures. We are now the sponsors of the MapDB project. I have with me Kotek. He's also a member of our team now, and he's joined forces with us, and he is the real genius behind MapDB. So we're gonna talk to you about that today. So I'm just curious, how many of you are Java developers? That's good because this is about Java. So it's good to know that there's Java interest at Cloud Expo. I'm glad to see it. So I'm just curious, in your Java development, have any of you ever had trouble with memory of your application? Running out of memory? Anybody seen that? Once or twice? How about garbage collection? We've never noticed that, right? Garbage collection is one of the biggest problems we have in Java that really gets in our way. So what we're going to talk about is MapDB. It's an open source database. It's a very unique database in the way that it works. It's designed specifically for Java developers, and we've been using it in our company for a long time, and we decided it would be really a great thing for us to combine forces and expand the usage of the product. So just want to, there we go. So again, just as a way of introduction, Code Futures is behind the project now, and so that's really making it so that Jan can work on this project full time. Okay, so again, the problem with Java applications, the primary thing that we see is, right, it's a great productive environment, but the problem is that you have limited memory size and you have garbage collection problems. And when garbage collection kicks in, it can actually stall your application or slow things down dramatically. Very unpredictable, and that can be very difficult. And the other thing we know about Java is how many of you use Java collections like hash maps or things like that? Anybody use those? Okay. So those are the most common structures and data structures that you use in Java. And so most Java programming actually revolves around maps and sets and queues. And so these are the most common things. And what we know is that these maps and queues are the most common reason that you actually consume memory. They make a lot of objects. They're actually the thing that creates the Java heap problems, and they result in a lot of garbage collection because those objects all have to be destroyed later. So this is one of the things that MapDB is really designed to address. So I just want to give you a brief overview of the product, and then Jan is going to show you some actual live demonstrations. So you can actually see the product in action and see some code examples and how it really works. The first thing is it's the first Agile Java database. And why do we say that? Because it's completely flexible. It's very natural for Java developers. Yes? Yeah. Could someone get the door for us? That would be great. It is kind of noisy, huh? Yeah. They're setting up the booth floor over there, so I'll have to compete with all that stuff. Tell me if I'm not loud enough, I'll get louder. It's easy for me to do. So it's very natural for Java developers. Again, it's based on the Java Collections API. So if you know how to use maps and sets and things in the Java Collections, you know how to use MapDB already. You don't have, there's zero learning curve, and you can actually retrofit an existing application with almost no work. As a matter of fact, we've tried it, and sometimes with just a few lines of code, you can completely convert an application over to MapDB. It's easily configurable for many use cases. This is a very wow. It's configurable for many use cases. And how many of you use more than one database in your organization today? Let's say a relational database and a NoSQL database. Do you know that they all have different characteristics, right? You can set one for maybe is better for memory usage, one is maybe better for disk-based storage, one is better for objects. There's all kinds of different variations. The nice thing about MapDB is very easy to configure for the use case that you want. So if you want to specify the kind of caching you need, or the kind of engine that you're going to use, or the way the database is going to be structured, you can change that with just a couple of commands, and it's really fast to do. But it really makes it so it's very extensible, and it can do a lot of different jobs, which we found very useful. Also, the data structures are really flexible. So now, because you're dealing with maps, you actually can create a data structure that matches almost anything that you need for your application. I wonder, hopefully this isn't going to be a problem. So I'm not even using the mic, and it's carrying already. So basically, with the data structures, it's so flexible because you can really match exactly what your application requires. And when you do that, it basically makes it so that you can have very fast performance because you can put the data in exactly the format that you actually need in the database. That means when you get the data back, you don't have to do any work because it's already the way you want it. familiar with object relational mapping, how many people talk to a relational database using JDBC or something like that? So typically you have to do a lot of gyrations to be able to actually make it so that the data fits your application that you get back from the database. With MapDB, you have almost none of that work. It's also really, really fast, comparable to C-based engines. If you've seen engines like LevelDB and other types of C-based engines, essentially MapDB is as fast as those engines, and it's really, really nice, and it's all natively written in Java. And it's fully concurrent, so you can have complete transactionality and control of your applications. Okay, so I just want to give you a little history of it. There was a predecessor project called JDBM. That was basically the Java Database Manager. What that was basically a Java hash map on disk, is the best way to describe it. There were several versions of that project. It was about, I think, 12 years old, so it was around for a long time. Essentially, Jan was pretty much the sole contributor to that project for about the last 5 years, and he decided that he wanted to do a complete re-architecture using the same similar concepts to make a much more powerful database, and that's how MapDB was born. So again, it's a ground-up re-architecture. It's totally Apache licensed, so you're free to use it any way that you like. There's no strings attached. And we're very, very happy to say that we have just released MapDB 1.0. That's after pretty much a solid 1 to 2 years of work, so it was really quite a big effort to actually get this out. Okay, so I want to just show you how easy it is to use MapDB. This is a simple code example. It's also an eye test. Hopefully you can read it to some degree. But basically the things in pink are basically the parts of map that are specific to MapDB. And what you can see is there's only a couple of different differences. The rest of the code is just standard Java code. So in this example, what we have is we have essentially a player object, and we want to, let's say it's a game application, and we want to keep track of players. And what we can do basically is we can create a database, and you can see the first command that we have is basically, if I can show this. Anyway, but you can create a database. This one is a file database. There are different kinds you can do in memory in different configurations. We turned off transactions. We said, go ahead and make the database, and that gives us a database object. Now in that database object, we just can create collections. And in this case, we're basically creating a tree map out of a collection, and we gave it essentially a name called collection name. Once we've done that, we can just do puts and gets like we normally do. So there's nothing after that. So the point is, those 5 or 6 lines is all you need to do to actually configure MapDB, and you're done and ready to roll. Everything else looks just like Java Maps. So it's really, really quick and easy to implement. And now that database could be 100 gigabytes. Like that's not even a problem. So we run tests with very, very large databases, and it works quite well. And then the only other factor is at the end, you do need to close it. So you have to close the database when you're done so that everything is saved properly and to keep the database integrity. But other than that, that's really all there is to it. All right. So I just want to talk a little bit about the architecture and what makes MapDB so agile and so flexible. One thing I know from dealing with databases for a long time, my entire career, is that databases are anything but agile. Right? If you have a database, it's very hard to make it flexible. It's especially hard to make it flexible in the way you configure it or what that kind of job that database can do. Some databases are better, again, using memory. Some are better using disk-based storage. Sometimes you don't need something so large and you want it to be faster in a certain way. You might need transactions or you don't need transactions. All those kinds of things with MapDB are just easy to use configuration commands. And the way the product is designed is essentially it's in 3 layers. The bottom layer is called the volume, and what that is that's the actual physical memory storage. We support out of the box 2 types of storage. One is disk and one is memory. That's really all it is. But that really is the simplest layer, and it deals with the direct device layer. The next one is the engine, which is the real key. And the engine is essentially where we actually define the storage structure and how the actual database is going to be structured, what type of capabilities it has. So for example, if it has transactions, or if it has caching, or any of those kinds of things, you can configure all of that in the engine. And then we put the Collections API on the top of it. And so that makes it really, really simple. You use the Collections API, but you configure the engine when you start it up, like I showed you earlier. So that's really all there is to the whole product, and it's even very feasible to extend the MapDB engines yourself. If you have new capabilities, you could even make one on your own if you wanted to. All right, So I'm just going to turn it over to Jan now. He's going to go over with you some of the MapDB features, and then he's going to show you some real examples. There you go.
Okay, I hope this microphone works.
Did you have a look out?
We disconnect
Huh?
we disconnect the mic maybe.
Yeah, I'm going to go get someone real quick.
Yeah. So basically MapDB is database engine. It means it's low level.
Just take it down. There you go.
Okay, so MapDB is basically the database engine, which means that it's basically low-level component on top of which you build your own application. And as such, it has a pluggable data model because
He's going to fix it right now.
so basically you can mix and match the components you want. Basically, there are separate components, and you can implement a component the way you want. So, for example, people are asking if MapDB has ACID transactions and if it supports MMCC. It's kind of hard to say because there are actually 3 different transaction implementation on top of the MapDB. And right now we are supporting ACID transaction in full MMCC, which means snapshot is a serializable isolation with snapshots out of the box in the third transaction mode. But basically it means that we have about 50 parameters, and the way you mix your settings in the DB maker, which is basically build the style factory, you will get set of the features you want. So for example, if you have some data store and you want to import it and create it very fast, you disable the transaction to have a fast import to create this data store very fast to populate it. And then you just reopen it with transaction enabled, and you will get full MMCC transaction transactions at the point. So another things in the MapDB are some sort of layers on top of the layers. So for example, if you want encryption or compression, you just add some sort of binary transformation which is providing encryption and cache and so on. So it's actually very simple to implement new features in the MapDB, and it's really Agile engine. For example, it's very simple. If you have a B3, you can have a B3 with directory nodes which will get preferential treatment in the cache, and if nodes will just overflow to the cache. But out of the box, right now, at 1.0, MapDB supports 3 transactional mode. One of them is MMCC. One of them are ACID transaction with snapshot isolation and serializable parallelization. If you want to see it right.
That's fine.
And we have lots of features like encryption, compression. We have about 5 different cache implementation, including MRU, random displacement, recache, soft cache. We provide like 6 different backends for the storage. One of them is on-heap memory, one of them is off-heap memory, one of them is using unsafe, there are memory map files, and so on. And basically, you can even configure some sort of overspill, so you can keep part of your records. You can keep part of your records in memory, and if they will expire, they will just overflow to the disk. So basically, MapDB is very simple to use, but it's a database engine, and you can configure it exactly the way you want, exactly to fit your needs. And typically, it gives you like 30%, maybe 50%, but even 10 times performance boost if you actually configure it properly to match your needs. MapDB provides implementation of Java util and Java concurrent collections. So, for example, if you have a concurrent navigable map and sort of advanced interfaces in the MapDB, in the Java util and Java util concurrent packages, we usually have an implementation. For example, if you take Java concurrent navigable map, there are actually 3 implementations which are passing all unit tests. One of them is in the Java util concurrent map package, which is skip list concurrent map. I'm not sure what's the exact name of that implementation, and 2 of them are implemented each in MapDB. So we actually took unit tests from various projects, including Google Collections. So it's very well tested, and basically, if I say we provide Java maps, it's not just map interface, but we also provide traverse, inverse directions, and so on. All those tricky nuances of the Java util maps and their concurrent implementations. We also have some other collection types like sets, queues, we have atomic records, atomic references, and so on. But most people are right now using maps because they have been with MapDB longest, and they are kind of most known because most people are using MapDB as a replacement for the key value store. Okay, so I think I will go to the code example. Can you read it well? Should I zoom it up a little bit? I could make it bigger a little bit if you have troubles to read it. Okay, I guess I will assume it's fine. But basically what's going on in here, we have a DB object. Oh, I should say first, entire MapDB is contained in the single package. It's a single jar, no dependencies. The single jar file has 400 kilobytes. It doesn't require any external dependencies except JDK, Java Runtime Environment 6, 7, and 8. It runs on the Android and various Java implementations. It doesn't use any undocumented API or anything, so it mostly works out of the box. We have a problem under certain conditions, but they can usually be worked around by enabling different mode. For example, memory map files usually don't work. Usually some sort of log files on the Windows, so we have some sort of workarounds by using different access modes. So basically MapDB is configured using DBmaker, which is factory style builder. So there are static methods which open the store. In this case we are opening the MapDB file and some sort of temporary directory. We enable encryption with password, and then we just call make. Various options like compression enable and so on are available through the ID auto-completion, so you just press Control Tab or Control space, whatever ID you are using, and you can see all the options which are available in the MapDB. Even the naming convention is kind of friendly, so it was basically made to be developer friendly. Then we have a DB, which is representing the container. And now we are instantiating one collection in here. Every collection has a name, so we can have multiple collections in a single store. And in this case, we are just taking a map, which is sort of BT. We have a second map, which is hash map, and they are both optimized for different usages. Hash map also provides some sort of caching expiry. But in this case, we just instantiated the map. In here, we are putting some stuff inside the map. MapDB actually comes with built-in serialization, which is sort of inspired by Creo, but it's kind of optimized to implement Java serialization to be drop-in replacement for the Java serialization. So it actually passes most of the unit tests for the Java serialization, but consumes about 10 times less space. It's much more efficient. And in here we are actually passing 1 and 2, which are for the keys. This sort of primitive values or primitive value wrappers get special treatment, so they are actually very fast. And we also get full poacher serialization with circular references and so on. In this case, we are just passing the player, which implements serializer object, and the player is basically part of our data model. So the collection, the content of the collection is those two records before, then we commit first on the disk. And then we kind of insert another record, and now we have 3 items in the map, and we just call rollback and discard the number 3 record, and then we just kind of sort of close the database. That's basically how it kind of works and look at feels. This example is using global transaction, which is second transaction mode. You can also disable transactions, so in this case the rollback has no option, but it's much faster. But also we have ACID transactions. In this case, you will use different factory to get DB object, but it will be basically the same code. Okay, so I think I'll move to the next example. MapDB is kind of built I originally started with the H2 database. I sent them some patches, some of them are integrated, some of them not. But basically MapDB was built because, or JDB and 2 and 3 were built because SQL databases have some sort of overhead. You have to serialize, deserialize, and normalize your data before you pass them through the network connection. And MapDB is basically working around it by kind of directly dealing with the store, so there is minimal overhead and zero copy. The serialization is much faster. But I also wanted to implement some sort of relational structures, like one-to-many relationships and so on. So MapDB has some sort of basic support for those. So in this case, we are creating a map with ID and player as sort of primary map, and we want to have one-to-many relationship on the player. So each player will have multiple games. So in this case, we are using multi-map, which is sort of hard or some sort of, it's not really hard, but rather than using separate interface, we are just using navigable set with tuple. It's basically works as sort of map, where the ID is primary key and the game is secondary key or value. But this way you can basically use it as secondary map. In here we create connection between one-to-many connection between the player and game. We just install the listener on the primary map. The B3 map and other collections in MapDB are providing listeners, modification listeners, so we can get actually notified when data are evicted, removed, modified, and so on. And this just, every time it gets new player, it just starts the game with AB content, and that's it, basically. And in here we just populated, now the size of the secondary is 6, because this binding keeps the secondary synchronized. And because this thing implements navigable set, you can basically query IDs which are starting with certain number, so which is done here. So in this case, we just query players associated with number 3. Okay, I'll get to something a little bit more interesting. Actually, some live code examples.
We're close to about questions.
If you could hold, yeah. If you could hold the mic.
Absolutely.
How we have time, sir?
We have about 3 minutes for questions.
Okay, so I will kind of skip the other code examples, but in this case, because one of the nice things about MapDB, because it's database engine, I can actually optimize the collections I'm using and so on. Okay, so imagine if you have a big tree, and if you are inserting stuff into the B3, you will have to update lots of nodes one at a time. But imagine if you have a pre-sorted data, and you can just create B3 in the streaming fashion. So you create bottom of the B3, and basically it's up and only operation. So it's linear performance, it's very, very fast. The performance doesn't degrade with the time. It's basically if you leave it running for 10 days, for a week, it will create several terabytes of storage, several terabytes of B3 without actually slowing down. So in this case, I'm